can just do it like this. So first I draw a circle. Then I'm saying the 4 projections. So it's kind of like this is kind of interesting. Yeah, how would I draw this kind of figure? So we have this, and then we have like a point M, where like this would be one of the projections, right?
No, I don't think it has to be a tangent. Like the way I just drew it is like a circle and then a random point, like 4 points on the circle, random point in the interior, and then like draw all the connections to point M and just the perpendiculars to those lines to like A, B, C, D.
Okay, so like this would be M, and then I draw, oh yeah, just the projections of M onto those 4 sides. Oh, but the projections are what lies onto a circle. Okay, so like I want BC, I want BC, A, and B to be the projections, right?
Yeah, so you just draw like perpendicular to BM through B, and the same for the other 3 points, and then you just get the quadrilateral.
Okay, so to BM through B. Okay. Let's see. Okay, so we don't really need this. Yeah, we can delete those. Delete and delete. AM through A, CM through C, and BM through D. And let's make the intersections look a little better. Something like that. So I have this, this, and then I rename them A, B, C, and D. So I'll call this A, B, C, and D. And those points I will call E, F, G, and H. E, F, G, and H. And obviously we have a bunch of cyclic quadrilaterals. And looks like Abdul heel is rejoining. All right. Hey, Abdul heel, thanks for rejoining. Okay, so we have this, 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 and this. We can move M around, and then we get different sorts of quadrilaterals. Okay. So N is a reflection of M over O. And now we want to show, so this looks a lot like isogonal conjugates, right? It looks like these 4 points are the...
Yeah. Yeah, they are the projections. That's really easy to prove. You just if you call the other intersections like whatever F prime, then just like the perpendicular bisector goes to O.
It's trivial. Yeah.
Yeah.
So this.
And that's also like
Oh, what?
the the fact that these four projections lie on the circle is also equivalent to M having an isogonal conjugate, and like its isogonal conjugate is N
Okay.
with respect to like ABCD. So
So
that's
yeah,
pretty cool.
this problem's too easy though, right? Yeah, it's just since O lies on a perpendicular bisector of IF, then NI has to be perpendicular, right?
Yeah, but that's also not the problem. I thought that for like a couple of seconds. But we have like another quadrilateral. We want to project B onto some sides.
B.
Yeah.
Wait, so you said that's not the problem.
The problem. No.
Oh, the projections of B, not the projections onto AM. Oh, okay, yeah, I got confused. Yeah, I see. Okay, so yeah, it's really a different problem. Okay, so this M and N are like isogonal conjugates in this quadrilateral. And so we have AM, AN, CM, and CN. That's interesting. So let's draw those. AM and AN and CM and CN. Let's make those, let's draw it so that those look easier. Show. Okay. So maybe if F and G, maybe if B is, yeah, more like that, it would be a little easier. So yeah, I want to make A and C a little higher up. Let me think of a way to do that. Like, I think what I want is okay, so C, I want C to be a little higher. There we go. That looks a little better. Okay. And now I'll drop perpendiculars. So AM, AN. So I'll call this, yeah, why not? PQ, and S.
You should make another tool, another GeoGebra tool for like feet.
Oh, I have that.
Like. Oh, okay, nice.
Yeah, I should have used that. So altitude. Oh, but I think it has to be like the segment instead of like I think if you have a point and a segment, it'll do it. Yeah, but the problem is it's not segment, it's like a line. So yeah, I'll make it better next time. For now, I'll just do it this way. PQ. Oops. All right. And I'm going to want to draw R and S. So CM and CN. Okay. That works. BS and BR. And CM and CN. that should be good. All right. And we want to show that those are cyclic. Obviously, they lie on the circles. P and Q lie on the circle with diameter AB, and R and S lie on this circle.
It is like the same as at the start, like n being the isogonal conjugate of m with respect to A, B, C, D. That was equivalent to the fact that, or the m having an isogonal conjugate was equivalent to the fact that the perpendiculars, the feet to the sides are cyclic. And the same way now, the fact that PSQR is cyclic is equivalent to B having an isogonal conjugate with respect to AMCN.
Okay. Okay.
And that conjugate is D. And we can show that for that the angles are the same at A and C, but I don't know how that works at like M and N.
Okay. So we have the quadrilateral AMCN, and we want to show the isogonal conjugate of something is D.
Of B. Because B having an isogonal conjugate is equivalent to these projections being concyclic.
Okay, so the isogonal conjugate of B, we want to show it's D. And we know that angle BAM is DAN. So that's half of it. And then we want to show that NDB is NDB, right? That's step 2, right?
I think it's, wait.
Actually, yeah, no, too slow.
Yeah, some angle condition on, wait, what is the angle condition? I think it's like M, wait. We want to show that AMD is CMB, I think.
AMD is, or ADM is CDB.
Wait. No, we know that. No, we don't know that. That's not true. I think we want to show that MD and MB are orthogonal with respect to AMC.
Okay. Yeah. So we want to show AMB plus CMB is 180, I think. I think that's right. So like this and this, I think we want to show add up to 180. Yes. Then the lines would be isogonal. Okay. Which is the same as saying angle BMP is angle CMB. That's another way to say it. And yeah, we have a lot of cyclic quads, so like those are cyclic. We know that. You know that this is cyclic. Wait, if P and M, why don't we have more points? Wait, why do we have 6 points on this circle. There should be another circle that has 6 points, right?
Sorry, on which circle?
So this circle right here has 6 points on it, right? Oh, because the problem isn't symmetric with respect to B and D. Okay.
Wait, no, I think we just have the same circle over D, no? Like,
Yeah, but the thing is, we drew the projections from B onto those lines, but we didn't draw the projections from D onto those lines. So that's
oh yeah. Oh yeah, you're right.
But we have this circle. And so we want to show that DMP equals, or DMC equals BMP. BMP is BFP, so maybe that would help. We want to show DMC is BFP.
I think we can delete almost all of the problem. I think we just need maybe like A, B, C, D and this circle at the start. The like points, like the projections are almost entirely irrelevant, I think.
Yeah, because
Like at least the ones from B. I don't think they matter at all.
well, so if M and N, yeah, they really don't. I agree. So I mean, if we know M and N are isogonal conjugates, okay, we know so basically we know that angle ADM is CDN. We need to show that we need to show that angle AMD plus BMC is 180, right? Like that's what we need to show, right?
Yeah.
So yeah, I agree. We can hide all this stuff. Well, I can keep that, but I think I've seen this kind of problem before. I don't remember how to solve it, but it looks very familiar.
Yeah, yeah, I think I've seen like sort of, I don't know.
Yeah. Um, okay.
Showing on it is just angle chase.
It's just an angle chase?
Yeah, we have 4 cyclic quadrilateral
Okay.
at corner.
Oh, yeah. So like AMD plus BMC, we want to show that's 180, but then we could use all the cyclic quadrilaterals. Yeah, I see what you're saying, right?
Yes.
So AMD is AME plus TME, which is AFE plus TKE. And the AFE, there's a bunch of different ways to look at that. So yeah, it's probably, yeah, just an angle chase, like that. Okay. So let me write this on paper and then I'll type it up, but it makes sense. So we want to show, so angle CMD is CMH plus TMH, which is CGH plus DEH. So that's one of the angles, and then angle AMB is angle AMF plus angle BMF, and that's angle AEF plus BCG, BGF. So so let's think about that. So CGH plus DEH is AEF plus BGF. So AEF, we can write. So we want to. So we have arcs EF and GF. So when you add them up, you get GE, and we want to relate that to arcs. So that would be JGH. Sorry. So CGH.
Use that EFGH is cyclic.
So JGH and so LEH. So JL. Okay. So I think I want to relate arcs JL and EG. Are those arcs equal, JL and EG? Sorry, what were you saying? Is it obvious that those are parallel?
Yeah, because MG and NJ are parallel, and also ME and NL are parallel.
Oh, so it's a homothety. Okay.
Yeah.
And I think that solves it. Okay. I'm just looking over my angle chase that I did. So we want to show. Oh, we want to show those add up to 180. Oh yeah. So. Okay. Let's.
I did that angle chasing, angle chase part.
You got the angle chase?
Yeah.
All right. Yeah. Do you want to type it up in the chat, and then I could paste it here?
Okay.
All right. Thanks. Yeah, it's an interesting idea. So I'll start out typing up the beginning of the proof. So, so it's well known that M and N are isogonal conjugates with respect to ABCD. To ABCD, and then we want to show that they are isogonal conjugates. We want to show that B and D are isogonal conjugates with respect to AMCN. Yeah, so it's like an isogonal conjugate. Something, I don't know. It's interesting. And then we have angle BMC. Angle BMC plus AMD. AMD. That's equal to angle BMG plus CMG. Actually, yeah, I think I might have it here. Plus angle AME plus angle DME. And then, yeah, I think I can do it here. But thanks for offering. And then that's BFG plus CHG. And then AME is okay, maybe you found an easier way to do it. So let's see. All right. Since it was 180. All right. Whoops. Let me make this a new line. So BMC plus AMD is BFG plus CHG plus AFE plus DME. And it's because EFG plus EHG is 180. Oh, nice. Yeah, because I see how you did it. You said EFG is 180 minus BFG minus AFE. And I like that. All right. So thus B and D are isogonal conjugates. And so then that's just the definition of so thus B and B are isogonal conjugates with respect to A and Bn. Thus, the feet of the perpendiculars from B and D, the feet of the perpendiculars from D to each side lie in a circle. All right, I think we've got this. Perpendiculars from B to each side of A and Bn lie on a circle. All right, we can move on to the next problem, but yeah, thanks a lot for that. So yeah, this is a very useful property, it looks like, for what do you call it? Isogonal conjugates in a quadrilateral. All right, so Thailand likes X circles a lot, it looks like. So we have the in circle and the X circle. This looks kind of easy, but we'll see. I have to fix the tool. Okay, so touches BC at D and AB at F. Then we reflect D over C. That's kind of interesting. Oh no, this should be D, sorry. And BC, that's still F. You could call this, passing through the points K, let's call this J, let's call this I, and then L, or no, let's call it P. Okay. So reflect D over C. That's D prime. Interesting. And circle passing through B and C is tangent. Oh, I think there was an IMO problem on this, where you find like the circle passing through B and C and tangent to this, but I forgot how to draw it.
We had this a while ago. I think there's a theorem like I think I don't know, I don't remember who said the theorem, but it was like Protosov's theorem that like BTC or like wait, I think TI is the angle bisector of BTC, but I don't know how to construct it with that. Maybe that doesn't help at all.
I know there's an IMO. I know there was a problem I did on my channel. I think you draw the altitude or something, but it shows how to construct that point T. Let me check earlier on my channel. Yeah, it was like before I did all the live stream videos. Let's see. Might have been like video 40 something or something like that. Let's see. But yeah, I feel like it would be kind of silly to re-solve that problem if it ends up being used in this. It is problem 34 on my channel. So it's on the IMO shortlist 2002 G7. Okay, you draw the altitude. Okay, so here's how you do it. You draw the altitude, and then you draw the mid. Oh, I can use my altitude tool. Okay. So there we go. And then you draw the midpoint of it. And then you see where does DH intersect to the circle. And that is how you get that point. So then BTC, if you define P this way, then BTC is tangent to the circle. All right. So let's draw that. Then we have J. We want to show TF, BJ, and B prime are cyclic. Interesting. All right. It's a cool problem.
I think the altitude is a distraction. TT just goes through J as well, which I think is much more useful in this problem.
Oh, T or what did you say goes through J?
J, D, and H are collinear, so we don't need to draw H for
Oh,
this construction.
that's a good point.
Because it is well known that like AD intersects the X circle at like the point that is opposite to K, and
Yeah.
then it's just
Just because ID is parallel to KJ, so if you do a homothency, it'll take ID to that diameter. Yeah. And then, yeah, the topmost point of this goes to K, so. Okay, so T is just the intersection of JB with the circle.
which video did you say was where you proved that that is also tangent?
Video 34. So before I did the live stream
Okay,
geometry,
thanks.
so it's also IMO shortlist 2002 G7. And yeah, I didn't even realize this, but maybe this results in like an easier proof of that fact. But yeah, it wasn't that long of a video, but yeah, it's an interesting problem. Okay, let's hide that label. So maybe let's see if we want to do power of a point or do an angle chase. We could try to show angle TFA is TJB. That could be our first step. So TFA is TDF. And it looks like we have someone else joining. Let's see. Hello. He's still connecting. All right.
There's also BT. The angle bisector of BTC seems to be this line like TD or TJ or whatever.
Oh yeah, and I think I even proved that in the video. That is
nice.
bisector. But yeah, and that's a good point. Hey Al Kadim, thanks for joining us. So we have a little under an hour left, and we're on maybe the fourth problem. I don't remember.
Yes, hello.
Hello. Where are you from?
Mauritania in Africa.
What?
Africa.
Africa. All right.
Yeah.
Cool. Thanks for joining us.
Okay,
but yeah, when I did that video, yeah, I'm pretty sure I proved that. Yeah, this was the angle bisector. Let me just remember the idea. I'm sure it used harmonic conjugates somehow. Yes. Yeah, I mean, basically I drew like if you draw the perpendicular from I to AB, whoops. And so AB passes through, like if you draw this point, then it's like AD is the polar of this point with respect to the end circle. So yeah, it's like you can show that these all concur and yeah, let me see what I did. So yeah, I guess let me see, is MT tangent?
Why is J on that polar? Oh no! Wait, no, never mind. It isn't.
Yeah, AD is the polar of this point. So yeah, like if you let FP intersect BC at a point, then M lies on the polar of A, so A lies on the polar of M, and D also lies on the polar of M because MD is tangent to the circle. So AD is the polar of M, and so from there you have MI is perpendicular to AD. And I'm trying to remember from there, somehow I showed that like MT passes through the midpoint of this. Let me see. Eventually I showed that was an angle bisector. Oh, but yeah, it was closer to the end of the proof. Let's see. HK.
By midpoint, you mean like the point diametrically opposite of D, or?
Oh, I think I did an angle chase. Yeah, no, the point diametrically opposite of D. I showed that MT passed through that point, and I think I showed that using an angle chase or something. And yeah, and once you show that, then yeah, this has to be an angle bisector because M, B, D, C are in harmonic conjugation. So that was kind of the strategy. Yeah, with some angle chasing, yeah, that's kind of how I did it. So I'll hide that stuff for now. So yeah, for now, let's just assume it's an angle bisector. And I'll just say to see that video. Okay, so first, I think we could do D prime last. So first, show that TFBJ is cyclic. So that's the same as showing angle TFA is TJB. I think it's the same as showing DF and JB are parallel. Oh, and that's obvious. Okay. So I've shown that I can show that TFBJ is cyclic because angle TFA is TDF, which by a homothency is TJB. Actually, I might want to think about that. Is that obvious by homothency? TDF is TJB. Maybe not, but that would. Okay, so we want to show DF is parallel to BJ then.
They're both perpendicular to BI.
They're both perpendicular to BI. Oh yeah, okay. So then that does it. Okay, so TFBJ we know is cyclic. We just want to show that D prime lies on it. All right. Maybe we could try power of a point. Like we could show BD times 2CD is TD times DJ. That seems plausible. That would mean, I think that would mean if we take the midpoint of TD, we call it M. I think that might mean that M lies on this circle, which I think is, yeah, which is obvious, right? So yeah, I think it's just power of a point because we have that MD times DJ is BD times DC. And so if we double this and we double this, then it's still true by power of a point. That TD times DJ is BD times D prime. And so that proves it. Okay, so yeah, these problems are easier than I thought. Of course, we're using a whole nother problem. So, I already forgot what video that was. I'm at 34. So from video 34 on my channel, let's see, we have that dt passes through the midpoint of the A altitude. Then, but JD also passes through that, because, so I'll say let's reflect V over I. Let's call it X. So let dx be a diameter of the inner circle and ky be a diameter of the X circle. Diameter of the inner circle and ky be a diameter of the AX circle. Then basically a homothency at A takes XD to KY. Takes XD to KY. So if we know that, then that means that's what proves that JD and T are collinear. I'll say it takes XID to KJY. So JD and T are collinear. So midpoint, I could say the midpoint Z. And then here I'll just add in Z. That way it's clear. And then once we have that, so TF is parallel to, I think it was LD, or was it? I think so.
We used BJ parallel to FD. if that's what you
BJ
mean.
parallel to FD. Yeah. Okay, so we have BJ is parallel to FD since both are perpendicular to BI. And now that's where we do that first angle chase, which isn't too hard. So angle TFA is TDF is TJB. TDF, was that right? TFA is TDF is TJB. And that implies TBFJ is cyclic. And now we just use power of a point. So let M be the midpoint of TD, then IMD. So B, and then TMJ equals TMD equals 90. And that means that I am J. So that means IMBJC is cyclic. Let me change the T's to I's. Yeah, Thailand, I feel like these problems all just rely on knowing like well-known problems from other competitions. So it's kind of interesting, but once you know them, yeah, they're kind of easy. So this is cyclic, and then so MD times DJ equals BD times DC. To MD BD times 2DC, and that means that PD times DJ equals BD times BD prime, and that means that TFBJ B prime is cyclic. All right, so let's see if we have time for one more problem, maybe even more than that. So maybe this will be harder because it's more recent. Don't know. So AB is less than AC, which is less than BC. So BC is the biggest side and AB is the smallest. So I think this is probably good. Thailand has done very well at the IMO lately, so I don't think this should be that easy. So, okay, so we have interesting 2 X circles. So I can use my X circle tool twice. And I should probably just draw the end circle. So we have this. Oh, I gotta do all 3 points to use the tool. Isn't that nice? You got a tool to just do it all for you. I just have to fix it so that, oh, it drew this one. Oh, you know what? I think I made the tool so it does do the point. It's just that GeoGebra, when you have a line tangent to a circle, it doesn't always know that it intersects. And so it can't calculate the intersection. I think that's what's going on.
Yeah, GeoGebra is kind of weird. Like I think you should just make the point not make the point the intersection, but just the foot of the altitude, because that always exists.
Yeah, like from the in circle. From the X center to the side to the line. Yeah, I agree. All right, so the center of an X circle touching. So this is P, and this is Q. Let's change this to. Oops. Okay, I'll change. It doesn't want me to. Let me hide P1 and Q1. All right. So the it touches AB at D, so this should be D. It touches AC at E. And I'll just call this X just because I'm lazy. The circumcircle of ADE intersects PE and QD. So QD, PE. Maybe I should draw a taller triangle. Maybe it'll make it look better. So QD at G, and it intersects PE at H. Then we draw the line perpendicular to AG at G, and AH at H. and those should meet on the circle. Okay, so this is kind of interesting. So, I mean, basically we have the antipode of A is where these two are going to meet, and we want to see. This reminds me a lot of another problem. Didn't we do a problem using the isogonal line lemma where we took two lines like this and we saw where they intersected BC? I think you were on the session once when I did it. It kind of reminds me of that.
I don't remember right now.
It's all good. Okay. So it intersects. Oh, we want AB and AC. Okay, then it is kind of different. Because this would be S and this would be R. And this I gotta like hide R1 so I can see the other one. I don't know why it does that. So I think let me hide R1. Well, actually, okay, this I can rename. And this one I'm gonna hide. And okay. We want to show DE and RS are parallel. That is random. Yeah, I guess it's not that complicated of a problem statement. I just have to keep renaming everything. I don't know why so many points it like shows like more than one name. It's crazy. So I think I really had to hide S1. I don't know why it makes it that hard, but let's take S1, hide the label, and then what? So I need to hide K then. Oops. I get this to be, there we go. So I'm going to hide the K label. Now, what? Do I rename it? Tell you what, why don't I do this? Show both. Oh, now it won't let me rename it. Oh well. I'll just live with it. Okay, so you want to show DE and RS are parallel. Oh, but this, gotta make it R. It's a very random statement. So maybe I could try showing like AR over AS is AD over AE, because we know AD and AE kind of pretty well.
There's a very nice point on. Oh wait, never mind. Oh, but the points QE A prime and A prime DP are collinear. Just because it's another right angle over AA prime.
Okay, A prime DP and QEA prime. Interesting. That makes sense. Almost looks a little bit like, well, I was going to say Pappas, but I'm not sure. I wonder if these concur, because then maybe it's like, could be the SARGs. Yeah, it looks like these concur. So QD, EP, and RS. So what if we start out? What if we try to show that RS and L are collinear, and maybe that's just like the SARGs or something. And then we show that RS is parallel. So if we have triangles PHD, actually, okay. Like PDH and QEG, what happens when we try to use the SARGs? Yeah, because HR and GS concur at 8 prime. And PD, yeah, are there any triangles that are like perspective from A prime? So
I'm not sure about that, but the fact that LRS are collinear is just Pascal's on like ADGE A prime.
oh really?
Like the 6 points on the circle, yeah.
Okay. Oh yeah, it's just Pascal's. Yeah, we don't need a SARGs. So AHD A prime EG. And do we have any cyclic? Maybe AL's. Oh yeah, it looks like AL is perpendicular to RS. I don't know why yet, but it looks like that. Let me just make sure. I'm pretty sure, but yeah. Okay. So for some reason AL is perpendicular to RS. And if we could show that, would that solve the problem? Maybe. I don't know yet. Oh yeah, if we could show AHRL is cyclic, so if we could show AL is perpendicular to RS, that solves the problem. Because then ARL is AHL is AHE is AD. So yeah, what's a good way to show that? Maybe we could define L to be the foot of the altitude from A, and then we could try to show those collinearities. Um, I'm not going to give up on making this I. This just bothers me. So if there we go. Now we can rename it. All right. Now this I1. Okay, so I think I want to do hide object. And then now I can rename it. There we go.
Yeah, if we prove that EL is perpendicular to RS, that then the problem is solved.
That AL is perpendicular to RS, right?
To RS, yeah.
Yeah. So that was
yeah.
all right. So actually, I wonder. Actually, yeah, I don't think this is true. I was wondering if PDEQ is cyclic, but no. But yeah, if we let RS. Oh, what happened? Oh, this is point Y right here. If we label these points, then we get some more cyclic quadrilaterals, I think. Like A prime L H O and this. But I don't know if that really helps. Unless there's something special about point O. I don't think so. All right, so I'm going to get rid of those points. I don't think they do anything. So, I mean, we want to show that HAD. How do we define H? We want to show HAD equals PLR. Wonder if there's like another circle through R and L. RL. So RLAH, we want to show that cyclic. But I don't know if I see another circle like that. Maybe RLI and that point? No. Yeah, that's not gonna work. This is a good problem. I have about 15 minutes left. So yeah, let's see where we can go with this. So AD over AE, we kind of know AD over AE is BV over VC. So we want to show AR over AS is BV over VC. In fact, if we drew the, I'm not going to do this, but if we drew the point T that we had in the previous problem, then BV over VC would be TB over TC, and we'd want to show that's AR over AS. Should be kind of interesting.
So there's another interesting point. The north pole of BAC, or I mean, I don't know if North Pole is like generally well known, but like it's just the where the exterior angle bisector intersects the circumcircle. In Germany we call that North Pole.
You want to draw this? You want to draw the circumcircle BAC?
Yeah, and I want to intersect it with PQ, or with like, which is just the bisector at A.
Okay.
And that also lies on ADE, which is cool.
Interesting. Okay. Because so let's give it a different name. So call it U. We know that AU A prime is 90. Okay. So let's think about that. So we're assuming we know that P, A, and Q are collinear. Oh, and we know that passes through the midpoint of arc BAC, so like the North Pole, like you said. And we want to show that is it obvious that these three concur?
I think yes, by spiral similarity.
Okay.
Because BD equals C and
Because BD equals CE. That makes sense.
yes.
Yeah. All right. Where are G and okay, so G and H. Hmm. All right. Maybe, so yeah, a homothency would take L to the perpendicular from A to D. I don't know if there's anything special about that point. Yeah, we could try to use homothency here. So, for example, where would that homothency take H to? Let's see. So if we drew this and this, first let's see what it does to H. So we want to draw the, I guess we could do it this way. Take H to this point, which doesn't look particularly special. Oh, we could have just drawn the line parallel to I and see where it meant that. All right. But wait, is that obvious that WI would be parallel to RL? It's kind of interesting. Oh, is IDO similar to HRL? I think so. It's kind of what we're saying, right? I wonder if HRIL is, well, it's not a parallelogram. Let me check if those are similar. So, they're so close, but they're not similar. Okay. Right. We have 8 minutes left. This has been fun today. The proofs weren't super long, at least not usually, but I feel like there were kind of interesting problems.
Yeah, I agree.
Yeah. Yeah, like they seem like they were things that could be used in other problems, like, which is helpful. So if we assume that these are cyclic, what is there anything else we can figure out? Can we use the radical axis theorem somehow? We have a lot of circles passing through A. It's possible that we could invert. If we define L to be the foot of the altitude, then we want to show PL so then we'd want to show that those are collinear. That would be one way to try to do it. So we would know that PH and E are collinear, and we'd want to show that L also lies on it. Let's think about that. So if we define L to be the foot of the altitude, we have angle HLR is HAR is HAB. No, HLR is HAR is HAD is HED. So HLR equals HED, but we don't know that they're parallel, so we can't say they're collinear. It's interesting. Is there a different way to show they're collinear? Let's see. We use a lot of signs to get AR over AS. So AS, like sine of ASG, that would be AG over AS. Yeah, G is just defined in such a weird way, so it makes this tricky.
Oh, I don't know if we had that already, but like I think with ALSH with the circle we are done.
ALS.
Oh wait, no, Sorry, ALSG.
ALS.
I think I switched like names of some points in my sketch.
Oh yeah, if we can show this as cyclic, that would solve the problem. I agree.
Yeah. Okay. Because that's just rhymes then.
Yeah. But also I realized that I think if we show this as cyclic, that would solve the problem. I didn't even see that before. But because AD over AE is AT over AF, and we want to show that's AR over AS. So, and then by power, if you rearrange that, that's the same as showing that this is cyclic. So yeah, I'm surprised I missed that, but I wonder if it's also the same as showing that DTFE is cyclic. Yeah, I think if we just show DTFE as cyclic, it solves. Actually, I'm not sure. Well, we know DTFE is cyclic. That's trivial because AT times AE is AD times AF. So then if we could show this is cyclic, that would solve it. Maybe TF, RS, and some other point concur, or some other line concur. Yeah, I don't think so. Doesn't look like it. All right, let's stop here. So thanks everyone for joining and participating. This was a fun session, and maybe next time I'll look for some more problems from Thailand. I'll try to find ones that can't be solved super quick. But yeah, let's see what else they have. So for everyone joining, or sorry, for everyone watching on YouTube, if you want to join us next time, feel free to email me at mgreenb801@gmail.com. We meet every Sunday at 8 a.m. US Central Time. So thanks again and have a great day. See you next time. Stop the recording.